Of this video is to see that it's the head difference which causes flow. We're then going to actually come up with a definition of head, and then we're going to do a couple of examples. So we need to ask ourselves a question: what causes flow? And I've actually only recently just understood this. So there's two things that cause flow. The first thing is elevation. Okay, an elevation difference, so elevation triangle, I'm denoting difference, so a change in elevation. So for example, say we have a bucket, okay, and we have the ground, and this bucket is filled with water. So this water, because of the elevation difference, will flow to the ground, okay? So height difference causes flow, and the second thing that causes flow is a pressure difference. Okay, a change in pressure. So say for example we have a pipe, okay, and the pressure at point 1 is 100 kPa, and the pressure at point 2 is 10 kPa. The water is going to flow from a point of high pressure to a point of low pressure, okay? So these are the two elements which cause flow. So what we come up with is this new word head, okay? And head is defined as Z plus the pore water pressure, or just the pressure of any fluid, divided by gamma water. So this is specifically for water. It could be the pressure of oil divided by the gamma of oil, if you wanted to, okay? So this definition of head considers both the elevation as well as the pressure which cause flow. Now head is in meters. When we get the pore water pressure divided by gamma W, we get meters, which is the same as Z, which is meters, right? So an important thing to note is that the head is determined by something called the datum. Now the datum is what you select. You can choose your datum anywhere. So if we were to do a quick example, say we were to have a container. Okay, in this container we have water. Okay, and we're going to now put our datum down here. So it's just a datum is the point of reference, a point of reference essentially. That's what it is. Okay, and we want to know the head at point A, which is say 4 meters above our datum. Okay, and we can also say that at A, the pressure at A is, let's make up a value, 20 kPa. Okay, so the head will equal the height above our datum, so 4 meters, plus 20 kPa on the gamma of water, which is 9.81. So we get an answer of 20 divided 9.81 plus 4 of 6.04 meters. So that is the value of head above our datum here. Now what does this mean conceptually and graphically? What it means is that if we were to come and stick something called a piezometer in here to our datum, so piezometer is like a tube, okay, the water would rise up from our datum, so it'd come up this tube to a point which is 6.04 meters above our datum. Okay, 6.04 meters. So that is how we actually find the value of head. So the value of head is from a datum, which you can select. I could have put my datum there, I could have put it there. It's convenient just to put it at the bottom for this example. And what it physically means, head, is that if I were to come and stick something called a piezometer, which is a tube, you can Google it, the water would rise to a point 6.04 meters above my datum. Let's just do a couple more quick examples. So hopefully this example will illustrate why head is the main criteria in causing flow. So let's say we have a pipe, right? So here's our pipe, and we're going to put the datum here. So say here's the floor, and we want our datum to be there. So here's our datum. Okay, so datum is the point of reference. We want to know whether the flow is going up or down, and to make it a little bit more tricky, the pressure at 2 is 100 kPa. The pressure at 1 is, let's make it 200 kPa. And this elevation is, say, 6 meters. So the height of this pipe is 6 meters. So hopefully it makes it a little bit clear, right? If we were to think of the cause of flow as being elevation, the water would flow down, right, from a point of high to low. But then if we think of it as pressure causing flow, the pressure is higher at the bottom and lower at the top, so the flow will go up. That's why we need this definition of head, to take into account both the elevation difference and the pressure difference to determine whether this flow is going up or down. So let's work out whether this flow is going up or down. So the head value at point 1 would equal 0 meters, because we're at our datum, plus the pressure at 1, the pressure at 1, which is 200 kPa, divided by the gamma of water, which is 9.81. So if we work that out, it's just 200 divided 9.81, we get 20.4 meters. The head value at 2 would be Z, which is 6 meters, plus the pressure divided by the gamma of water. So it's 100 divided 9.81 plus 6, we get 16.2 meters. Okay, so the head at 1 is larger than the head at 2. So this now confirms that our flow is going up the pipe. Okay, so it would have been impossible to determine whether the flow is going up or down just based at looking at the elevation difference and the pressure difference. We had to use this definition of head. Okay, just one other quick example just to hopefully illustrate another point. If we were just to have, say, a bath of water, right? So here our water is, which is, say, 5 meters. And we want to know, okay, and we can prove that this is static using head, right? When I mean static, I mean there's no flow, okay? So let's say the point A and the point B. This is our datum, right? The head at A would equal Z plus the pressure at A. So there's no pressure at A, so it's just going to be 5 meters. And the head at B, similarly, is just 5 meters and there's no pressure, so it's 5 meters. So you can see that the change in head is 0, which means that there's no flow from A to B because there's no difference in head. I could have also put the datum somewhere else, and I could have put the datum, say, here, and we would have found a similar answer. Okay, say the datum was 2 meters below the surface, right? The head value at A would be 2 meters, and the head value of B would be 2 meters, right? Although we're getting a different value of head, we can still see that our change in head is 0, which means we're still not getting any flow. So the head value is a bit arbitrary. What's important is to look at the change in head to see whether we're getting a flow and which direction that flow is going, as we saw in the previous example. Alright guys, I hope that helps.